Hello again, welcome to Matematika channel. In this video, we're gonna revisit this problem that we solved earlier on the previous video by using the undetermined coefficient, which is basically a fancy name of the method by intelligent guessing. Okay, so how we gonna do this problem again now? Okay, so first of all, we need to have some review. So if we have px a polynomial, say usually we compute px times e to the x dx using some some partial integral. Then we have something like this, px e to the power of x minus the derivative of p, let's just call it another polynomial, qx e to the x dx. Since this is the derivative of p of x, then we know the degree of q is smaller than the degree of p. Okay, but we can interchange this integral with that integral and rewrite the integral as something along integral q of x e to the x dx is equal to px e to the x minus integral of px e to the x dx, which is now the new integral, the polynomial. Its degree is greater than the original one. So what I'm trying to say is that applying the partial integral can reduce the degree of the polynomial, and as well we can increase the degree of the polynomial. So how we use this fact in our problem? So we are expecting this integral, we can reduce the degree of this, and meanwhile we are trying to increase the degree of this, and somehow we meet somewhere in the middle. Okay, so let's look at this integral, and we want to express this as u dv. Okay, as u dv. So we wish our v to be equal to e to the x squared. In this case, then the v will be 2x e to the power x squared dx. So let's separate this, 2x e to the power x squared dx. And in order to get back 4x to the fourth power, we need to multiply by 2x cubed. Okay, so this is our u, and that's our dv. So according to partial integral, then we have u times v. Remember, the v is this guy, so 2x cubed, and then the v is e to the power x squared minus integral of v du. So the derivative of u is 6x squared, so it's become minus 6x squared e to the power of x squared dx. Okay, now on the other hand, we try to increase the degree of the polynomial 1 here. Okay, so now we call this as our u, and that's our dv. So then u times v is x e to the power x squared minus integral of v, the v is x itself. Okay, so don't forget we need to multiply everything with 3. Okay, x, and then take the derivative of e to the power x squared, 2x e to the power x squared dx. which is 3x e to the power x squared minus 3 times 2, 6 x squared e to the power x squared dx. Okay, so let's write this down as 3 e to the x squared dx. Remember, that's the original problem. In order to get this expression, we can do that by subtracting this thing from that thing. Okay, so by subtracting the second equation from the first one, we have 4x to the 4th power minus 3 ex squared dx. That one minus that one is 2x cubed minus 3x e to the power x squared. And then this minus that, look, that expression is exactly the same as that expression. So when we subtract this from that, we get a constant. Why it is not equal to 0? So because this is the general antiderivative, which is, let's say the antiderivative is fx. So the general antiderivative is fx plus a constant, and this is another fx plus another constant. So then the difference is a constant. So there you go. You have the answer. Alright, thank you for watching. Don't forget to hit the like button if you like the video. If you have not subscribed yet, please do subscribe, and you can follow many interesting videos from our channel. Thank you for watching. See you on the next video. Bye bye.